Over the last few years, the capabilities of AI systems have exploded. AlphaFold 2, mu0, Clip, DALL-E, GPT-3, and many other systems have extended the reach of AI systems to new problem classes, and there's a lot to be excited about. But as we've seen in other episodes of the podcast, there's a lot more to getting value from an AI system than jacking up its capabilities. And increasingly, one of these additional factors is trust. You can make all the powerful AIs that you want, but if no one trusts their output, or if people trust it when they shouldn't, you can end up doing more harm than good. So today I'll be speaking with Ayanna Howard, a roboticist, engineer, entrepreneur, and the dean of the College of Engineering at Ohio State University, where she focuses her research on human-machine interactions and the factors that go into building human trust in AI systems. Ayanna joined me to talk about her research, its applications in medicine, education, and the future of human-machine trust on this episode of the Towards Data Science podcast. Yeah, I'm really excited for this. I was excited about your research. I was excited about your lab, all the work you're doing, and then I started looking into like your bio and your background. And there's just so much stuff there. Like one day, I hope that my Wikipedia page, which is currently non-existent, but I hope that one day it will look half as good as that. So I'd love to talk to you first about your journey into AI, because it started back in the 90s, which was kind of an interesting time for this technology to begin with. Can you speak to that a little bit and kind of lay out that journey?
Yeah, I know, which is so funny. I've been doing AI, artificial intelligence, for, now almost 30 years almost. And people are like, really? Like, how did that happen? But, my very first job was in the summer at NASA. So, official job. And at the time, we were using neural networks. And we were doing, looking at data with respect to the train and trying to map, basically rover traversals based on this information. And, it was like, oh, we can learn the characteristics based on, how we did it in the past. And of course, then, it was, if I had one layer, it was like, oh, I can have a layer. Can I add in another layer?
Yeah.
And not take 2 weeks to train? Right. And so it was a different types of approaches of how you think about data, of how you think about outputs. But some of the fundamental theories were very, very much the same. Of course, it evolved, but then it was about computer vision, it was about neural networks, it was about learning, and it was also about human-robot interaction.
And in those early days, neural networks, of course, with Jeff Hinton, we're all used to thinking of like maybe AlexNet as the moment in 2012 when things became really hot for neural networks. Was it different working with them back then? Like, I guess, as you alluded to, like the compute restrictions and it takes forever to train these things. I'm curious about what were some of those constraints? What were some of the factors that went into deciding, okay, let's use a neural net for this or let's not?
Yeah, so my favorite back then was backprop, which is like, what's backprop? So, but it was, and there was a bunch of different kind of methods. I actually liked backpropagation. At the time, it was one of the fastest. But caveat, what are the constraints? So one of the constraints was that, the amount of inputs, the amount of hidden nodes in your layers, the amount of layers, and even your output was the biggest constraint because these things took so long to train. And what that meant was that, if you didn't get it right the first time,
Yeah.
you could train for, a whole 2 or 3 days. You would press go and you walk away. And then you look, you're like, oh, why is it not converging? Right? Because you set your parameters for what you're looking for convergence too high or too low in some cases. And so that was kind of what it was. And you didn't want to babysit, but sometimes you would babysit so that you could see, okay, is the error going down? Is it going down far enough? Right. But then it was like, 0.00001 difference, 0.000, right? It was like, oh, I think it's working because it's going down in terms of the error, but it's taking such a long time. But it also meant that you understood your data. So this is the difference. So back then, and I would say now, a lot of people use these learning methods and they don't understand the data, right? It's like, oh, I'm just going to throw it at, this algorithm and it doesn't work. I'm just going to use another algorithm or, scramble my inputs. Then you have to be very careful about the data. How do you represent the data? How do you normalize the data? What are the ranges of operation? What are the features that seem important? And so you had to do a lot of that internal, I would say, human coding because if you didn't, you can just throw it. I mean, it would take you years then to actually come up with something useful. I think that was when I learned how to appreciate data,
Mm,
really understand what it meant, understand from a very theoretical level, like what are the ranges of this data that are possible, right? Why is that? When I get anomalies, because I have, maybe my range is from, if I think about computer vision, like maybe my range is in that 256, and then I got a score of like 500. How could that possibly happen? And then
right.
understanding, oh, there's noise in camera data, right? And so you really had to understand, and in that case, love the data that was being used to train the algorithms.
It's interesting, especially now that we've entered this era of like gigantic models that we're outsourcing all of our cognition to. Basically all the feature extraction, all of that stuff is now being done by the model. And I guess it starts to speak to some of that interpretability stuff that we'll be speaking about in a moment too, right? Like to some degree, if you're doing more of the thinking than the machine, you can define these features that are more human understandable. I guess, would it be fair to say that neural nets back then might have been more interpretable?
I would say they were. But it was only because there was a lot more human in the loop
Mm,
in terms of understanding. As an example, one of my early projects at NASA was doing identification of different types of planes and their orientation, right? Because we wanted to be able to look at, as satellites were descending, what is their orientation, and can we get a system or a robot to understand where it was going? Right. And so if you think about planes, like now you just take a bunch of images of planes and throw it. But then we have to think, okay, what are good features of a plane? Oh, it's the wings and maybe it's the tail, right? So let's think about how can we extract that? Well, maybe we should think about a PCA in order to extract these dominant features because we're like, oh, this is easy to see from us. A PCA
yeah.
should be able to really, right? And so that's really what it was. But a lot of that meant that when you had the output, people would look at it and would be like, oh yeah, that makes perfect sense.
Yeah.
Because of course we were curating, we were artisans
Yeah.
in
Yeah. Yeah.
constructing this.
Yeah, well, I guess with that comes a little bit more, as you say, it's more of an art than a science at that stage because you can't run maybe the same kinds of repeatable experiments. There's more fine tuning being done there. I'm curious as well about your perception of how the field itself was perceived by the public back then and then today. Because, of course, there were the Terminator movies, there was, some hype and buzz back then too. How do you think human, maybe trust of machines might have changed? How do you think the general public perception of AI and robotic systems has shifted over time?
Yeah. So what I want to talk a little bit to answer that question, the difference between AI and robotics back
Mm,
then versus now. So back then, even though I was using computer vision and neural networks and PCAs, I considered myself a roboticist and not a person who did AI. Even though now you're like, wait, you're totally an algorithms person. But the reason is because if you thought about people who were doing hardcore AI, it was you couldn't really think about the application necessarily. It was about the theories. It was about the love. It was about can we create smaller data sets or computational ways of doing this. Whereas in robotics, it was okay. Let's get these tools and make them work, right? And so it was really
mm,
more about integration and again being the artist in terms of understanding how to construct and use the theories to actually work. And I will tell you, as a roboticist, it was like, oh, we do real work, right? Those AI folks, they just play. That
yeah.
stuff will never, ever, ever work. And the AI folks were like, yeah, but you're using stuff we developed 10 years ago, right? And so it was really two different camps, I would say. But what's happened in terms of the evolution is because now when you think about AI, it really is, I think of it as the algorithms that's associated with, either virtual or physical hardware. The camps have really converged. And so I consider myself a roboticist as much as I consider myself an AI person. Because back then I was an AI person, but there was these two different camps of how you thought about it. Whereas now they're blended. And so when I say that is the kinds of interactions our public perception of robotics and or AI back then was different than it was now. Back then, people's perception of AI was, oh, artificial intelligence? Yeah, I'm not quite sure what that is. Robotics, though, I know what that is.
Mm.
That's that bad stuff, right? That's the Terminator. That's the robots that are taking over jobs. That's the stuff that we don't like. But AI was more of like I don't even know really what that is.
Oh, interesting.
Totally different. Whereas now, we're all coupled together. It's like robotics and AI, they're taking over the job. It's kind of,
Yeah.
it's smushed together right now.
Well, and I guess we're also seeing some AI systems that independently can deliver enough value to be noteworthy without embodiment, and that's sort of adding a whole complicated dimension too here, right?
So as a roboticist, I actually think about the space of humans as either virtual or physical, right? And so when I even think about, you could say, oh, well, there's some AI, there's some algorithms that are really, it's not really a robot. But the fact is that it lives in our world. And right now our world is virtual as much as it is physical. And
Mm-hmm.
so when you have a language model, you're like, well, it's a chat bot. Like, why is it? But the thing is that it's living in this space of language, of interaction, which I can very easily take that and put it on hardware, and it now becomes signal that's transmitted through air. That
Yeah.
means you have to think about it pretty much the same in terms of what are the kinds of models that you're going to use, how fast can it be done, what is the interpretation from the human perspective. And so as a roboticist, I really think of AI is either in a virtual format or a physical format. In a physical format, there's other constraints in terms of the physics, but in terms of the algorithms, a lot of the same considerations have to be made.
Well, that's really interesting, especially like to me coming from the more sort of AI direction, if you will. I always would tell myself the story that, well, what happened was, AI capabilities increased and increased, and then at a certain point they became useful enough that, hey, they're driving value, rather than looking at like human behavior as the thing, or one of the key things that's changed, at least, where you see us spending more and more time in these mediums that don't require embodiment in the kind of traditional way.
No, but it's true. If you think about, basic AI, not the kind of power, but there was algorithms being used to do things in, for example, the military and ballistics way before people even knew what was going on.
Mm.
But yet people, I would say, because there wasn't the interaction, it was like there was no value in this,
Yeah.
but there really was value. It was just for a very specific, fairly narrow application, but it was being used in some cases.
Today, when you look at the domain of human machine interaction, first off, like, why is it so important today? Because it does seem to have attracted a lot more interest recently. What's your sense of what the spark was that really caused that to happen?
Yeah, so it was because, and you mentioned, AI having value, but it's actually AI having value for the public, for customer facing, consumer based. And that's the difference. Because now you're talking about the numbers. If you think about how many, billions of people that AI could possibly interact with, that's a lot of eyes and ears and language and all these characteristics that mean that a lot of people like AI or don't like AI and have this interaction. And so that's why this aspect or element of trust becomes much more important, because we use these systems now on a day-to-day basis, on an hour-to-hour basis. And a lot of our systems and machines are powered by AI. Not all of them, some of them, algorithms without AI, but a lot of them are powered by AI, which basically means that our interactions are going to be dictated by how much we trust, and I can define trust, but how much we trust the inputs that are being provided for me to help make my decisions, or maybe the machine itself is making the decision for me.
I think that's you teased a really good question there, which is, how do you define trust? Like, what are the things that matter?
Yeah, so my definition of trust is those actions that dictate my behavior. And so why do I say that? So there's a lot of concepts I think people think about trust, like, oh, do you trust me? 10 if you do, 0 if you don't. And I look at myself, I'm like, yeah, I don't trust machines, right? Like,
Yeah.
I'm gonna give you a 2. But I think that that's one a subjective point of view, and also people don't really understand themselves. Believe it or not,
Mm-hmm.
people do not usually do a self-deep reflection about their belief systems. It's just, oh, I think I feel this. Whereas when I think about trust, I look at your behaviors. If your behaviors dictate or show that you are trusting the decisions that are coming out of the AI, then you do trust the machine. You might not say it, but your behaviors and your actions say that your circuitry is firing such that I actually believe that the system knows what it's doing. And that's how, at least in my group, we define this trust.
Okay, so that's almost the first piece of philosophical bedrock that we've hit in the conversation, where there's this notion, right, of actual preference stated preference and revealed preference. And so, when you ask somebody like, what is your favorite color, let's say, they might tell you it's red, but then if they act in the world in such a way as to make it seem that it's blue, they keep buying blue cars, painting their house blue and so on, maybe there's a difference. So what is it? I mean, I don't know if you'll have spent much time sort of focused on in the weeds here, but what is it that makes revealed preference more interesting than stated preference in this context from your standpoint?
Because revealed preference is really the only thing that makes you function in the world, right? So I love your example about red or blue. So maybe you say, I really like red, right? But if you buy, which means there's a financial transaction based on blue, as a company, then I'm going to start catering and targeting you and triggering the things that show you blue, because I know that's what you're going to buy, right? And so as a customer, I might say I like red, but as a company, I'm going to bias my algorithm to show you a bunch of blue stuff because I know that that's going to trigger your shopping behavior.
Yeah.
So that as a developer, I'm interested in evoking that. I want your resources versus, I want you to feel good and you don't even know how you feel because you really don't like red.
I guess we could go even deeper down the rabbit hole here, but one thing that comes to mind is when we talk about revealed preference, often, at least I could be wrong, in my mind, this is associated with more short-term stuff. So, like my revealed preference is on full display when I'm like scrolling down Twitter, for example. What I click on, what I don't click on, what I share, what I like, and so on. Like it's my limbic system just kind of driving my behavior in this very raw way. Whereas before I sat down next to Twitter, if you had asked me for my stated preference, it might have been more aspirational, more altruistic, more long-term oriented. Is this a risk, do you think, in the kind of broader space of AI, focusing on revealed preference as a more instinctual kind of knee-jerk reaction type of preference class?
Yeah, so one of I focus on trust, but I also focus on bias, and so I actually believe that we can use systems to basically prompt people to go from their revealed behaviors to their stated behaviors, given that it's an ideal, right? And we're starting to look at that. So I might say, for example, and I'll use a gender. I'll say, you know what? I will equally hire a male versus a female engineer, irrespective, right? I might say that because I fundamentally think I believe that. But then maybe as a company, I look and I have all female engineers, right? And so you're like, wait, hold it, but there's equal preferences. How did that happen? And you can give, excuses. But the fact is that there's some aspect of a bias. So this is my reveal. I prefer, one type of engineer, gender, but I really believe that I'm fair and just. And so in that case, I actually believe that we can create an AI system that says, hey, here's your reveal. So we're going to kind of manage your data based on that. But you know what? We're going to do things like, every so often we're going to switch things around. Or every so often we're going to state something like, hey, by the way, you had 2 candidates and, the last 10 were based on, this, but I thought you said that you have, this equal preference. Like maybe we should have a conversation. And so I think we can use AI to push us toward being better humans. We don't do that yet. Not as a company structured, but I think we can.
That's its own fascinating rabbit hole. There's so much I want to talk about, but I do want to kind of linger on this just for another minute. Do you have thoughts about the kinds of mechanisms that you might use to accomplish that? You mentioned, I guess, showing examples of decisions that deviate from stated preference. Is that kind of the bigger strategy here?
Yeah, so I'll give you an example of one project that we're working on because it's very concrete. So what we found was that for so as you know, right now, facial emotion recognition, there's stuff on the news because it's biased with respect to race, ethnicity, sometimes gender. And what we found is in our own research where we looked at human coders, when humans have to code images based on what I call out of group versus in group, they're much more uncertain. So
And sorry, when you say code, like classify or like bucket?
classify, so
Okay, cool.
classified buckets. So maybe I'm looking at images and I want to, happy versus sad versus angry. If they're in group, i.e., if they're of the around the same age, gender, race, ethnicity, my certainty is much higher than when they're out of group, right? So we've been able to show this. Now, when we add in an agent, what we find is that the more uncertain you are, the more likely you are to trust the agent.
Ah,
So, and what we're starting again, statistically we don't have enough subjects in terms of statistical evidence, but what we find is that when the agent is basically, overriding which basically that you're wrong, you're actually able to readjust and learn how to do this better.
there's a phenomenon that called Gelman amnesia, where basically or sometimes called newspaper amnesia. You open the newspaper, you read an article that's written about your field of expertise, something you happen to know a lot about, and inevitably you see a whole bunch of things that are screwed up. Like sometimes the causality arrow is completely backwards, sometimes the conclusion is upside down. And then you kind of you go, oh wow, what a complete dumpster fire. And then you turn the page and you look at another article on a topic you know much less about, and you go, oh wow, what a fascinating story about what Selena Gomez wore to do her grocery shopping or whatever. And you kind of like forget about the disaster you saw in the previous thing. You have essentially amnesia as you turn the page. I'm wondering if something analogous happens here in the context of AI systems, where you see, because presumably they're classes, as you say, that you're very comfortable with, you're very confident about. Do people seem to remember those failures when they then go on to like these more uncertain classifications?
Which is interesting. This phenomenon actually works exactly the same with AI. And so what we've done, and we've used examples of self-driving cars where we've introduced mistakes early on, right? So it failed. And what we see is that, gradually people will be like, oh, yeah, okay, it's not working. But then as soon as we then have it do something correct, like basically it's correct, and we give some reason for it, that's like, oh, my, developer, it doesn't really matter. And I mean, literally, it doesn't matter even what kind of reasons we give. It could be like, it was rainy. What
Wow.
we find is that people will be like, oh, sure. Well, I just forgot that you were bad, like all of these, but now I think you're going to be good. Um,
Wow.
and we find that it doesn't matter how many times that it could be they were making mistakes one time, two times, n times, as long as right before you want them to make another decision, you basically say, I'm an expert. Here it is. I was uncertain. People will be like, oh, sure. I totally think that you're going to be right now.
Wow. So what does this imply about the ethics of providing justifications to end users for mistakes of almost any kind? Like, do you have any thoughts on that?
Yes, we're looking at this as well, because of course it means that you could manipulate people very easily as well. So that's the negative. And so one of the and so right now we have no solution of how to do this, because we actually are trying to figure these out, this phenomenon, so that we can then say, okay, here are this aspects. But some of the things that we know sort of works to maintain trust in the system, but also don't manipulate, is to provide people choices. So if you think about interpretability or explanations, if you give just the one, we find that people will be like, oh, great, that's the decision, even if it's, wrong afterwards. But if you give them more than one choice, one that's, correct and one that's like slightly incorrect, it makes people do a self-reflection, and they are more likely to make a better decision. Not necessarily the one that if the AI system had just said this one, they would have chose. And so it's about giving people choices, which makes them do this reflection of, oh, I do know what I'm talking about.
Yeah.
Wait, why? So it's that kind of trigger.
It makes me think as well of some of the best ways to just teach people or get people to be engaged in a process. Like, if you just tell them what to do, there's a sense in which we all kind of turn our brains off at a certain point. This feels like, incidentally, one of the failure modes of like autopilot, in like a Tesla.
Yeah, so there's actually a phrase for this. It's we go into this, it's cognitive bias. So this is actually how we function, right? If something is repetitive and it's done over and over again, what we like to do is that we change or remap our attention to something that requires us to think more, right? And so if you think about, self-driving, if it's doing okay at the beginning, we go into this, I don't have to focus, I don't have to pay attention. And therefore I can think about, the math problem, or maybe think about, the vacation, because that really requires me to process information, right? It's just the
Right.
way our brain functions in order to deal with all of the data and all of the decisions that we have to make every day. So by then providing these two things, what happens is it redirects attention back to I got to think about this. And then you just make better decisions.
And does the human machine team tend to make statistically better decisions when that sort of thing happens?
It does. So there's kind of a caveat is if you have someone who is what I call an expert, right? Always pays attention, is like, I don't believe in machines ever, right? Like that person coupled with an AI basically makes equivalent decisions. But anyone less than an expert, it actually is statistically better when you have this aspect of human machine teaming, where you give the person choices versus just having the machine make it with, again, the ability to make mistakes, just having the person make it with the ability to make mistakes versus the expert who will always be, optimal.
It's interesting how much though the psychology of the end user matters here, because like it seems like an ingredient that makes it really hard to come up with like a one size fits all solution, especially for commercial applications of this technology. Is there a way that you can assess a person's persuadability when it comes to these systems?
Yeah, but this is so, I always say people are fairly easy to model.
Hmm.
So there's, anomalies, right? Like you do something, every day exactly the same. And, occasionally you may deviate from the norm, right? But it's an occasional thing. Most people are fairly easy to model, or if not easy to model against the general norm, easy to model with respect to, okay, you belong in terms of this class of preferences versus this class of preferences versus this class of preferences. And the reason why is because we are modeled by our societal norms, right? There's an expected behavior from very early on that kind of dictates how we make decisions and how we function. And so when we're thinking about AI and modeling human behavior, what we're really doing is we're modeling these social norms that is just ingrained in us
Yeah.
from very early on. I will tell you, the most anomalous characters are kids. And so I work with kids in
Oh,
my
interesting.
research
Yeah.
because their norms are not set in stone yet, right? And so I'll do a study with like adults. I'll be like, oh, that's easy. I don't even need like a huge sample size because
Yeah.
they're all acting exactly the same. I do kids and it's like, oh my gosh, they are so deviating from the norm in so many ways and fashions, but it makes it also quite interesting and fun.
Well, I guess they say, yeah, personality is negotiated, right? So over time, we're all kind of constrained into this. Kids can be scary. One question I do have is actually at the level of the should we too, because we talked a little bit here about the kinds of challenges that are posed for people trying to solve these trust building problems with machines. But then there's, I guess, a separate question of like, should we try to build trust in certain systems? Because I could imagine a world where we get so good at trust building that pretty much it's a solved problem, modulo some edge cases, but where our AI systems are not as trustworthy and reliable as they should be to kind of warrant that level of trust.
One of the reasons why I say I work on trust and bias is to really focus on this aspect of our machines are not trustworthy unless they're also mitigating bias, right? And so if we just created machines that are easy to trust, and when I say that, i.e. manipulate human behavior all the time, it means that we're doing it not for the good of ourselves necessarily, but we're doing it for the good of our, financial bottom line, or, to get the larger market share, or these aspects that are not for societal good. But when we think about trust using that to help mitigate bias, what it means is that we're basing it on the manipulating of human behavior, because it still is that, but it's based on a societal norm. It's based on ensuring that we're doing this for the good of people, for the benefit of a society, of a world. And I think then it correlates very well.
And is there stuff about like recent technology that that has you particularly interested in the structure? We've talked about, for example, language models like GPT-3. That's definitely one category of thing. Robotics are getting more sophisticated with reinforcement learning, all kinds of stuff. Is there any particular area?
I'm an academic, so of course the areas I'm going to say are the ones that I work on, which is healthcare and education. Um, but so healthcare, and why I like healthcare is that you have both, AI and, both virtual and physical in all elements, from, diagnosis to intervention to even determining the, resources or the services someone should have. And healthcare is a area that is pretty much dictated by trust. Individuals come in to a hospital, a doctor says this, and you're like, okay, I'll take that drug at this dose. And very few people actually go and like, okay, what are the issues? What are the risks? What is the percentage that, that die from this? Very few people do this. So you already have this scenario where it's a trusted relationship. Now you introduce AI, which we're seeing. So now the doctors might have an algorithm that is helping them make a decision, or maybe they send the person home and saying, okay, use this app which has this method that's taking the data and providing this. Well, now you're even enhancing the trust in the AI because you're already in this healthcare scenario. So that's why I think healthcare is interesting, because it has societal benefit. Like if we get it right, it makes people better. We know this, guaranteed. If we get it wrong, we also know that it can make our lives worse.
And the doctor-patient thing is such an interesting aspect of this dynamic too, because there's this interesting thing where doctors tend to be very set in their ways and hesitant to engage with new technology, or at least that's a theme in Canada. I don't know if it's different in the American system. Is that something that is like an obstacle to overcome? Are there specific approaches, techniques that you've found work well to build trust there?
Yeah, so doctors are apprehensive of a new technology, but hospitals are not necessarily apprehensive if it helps them save costs.
Ah, okay.
Right. And so, and it's a constant battle. If you talk, and this is in hospitals, and then if it's in hospitals, of course, it then starts propagating into the, family practices and clinics. And so if you look at the kinds of technologies that are brought in, I talk about robotic surgery, like, even the Da Vinci system way back in the day. I mean, that was a really expensive piece of equipment, right? I mean, they had to do a lot of convincing in terms of, the doctors and the hospitals. And one of the things, and there's some history about this, but one of the brilliant marketing things is that they also got the patients to get involved, right? And so now it became this aspect of, yeah, it's expensive, but you have both the patients and you have the doctors. And now you're starting to show results that the equipment is expensive, but the follow-on costs go down. So even as hospitals, you're like, okay, well, if I think about long-term benefits, I'm actually saving money, right? But it was like this multi-pronged approach in order to get it adopted. And now, as you know, robotic surgery is a thing. We're seeing this in some of the radiology and the AI that's coming in terms of helping in the imaging space and radiology and MRI space. We're seeing this in the trying to refer services. So I have a patient, what kind of service should they get as a follow-up? AI is being used to do that. And again, hospitals like it because it's saving costs.
Looking at how doctors present this stuff to patients. So like the person who delivers, or how the insights that are AI derived are delivered to the patient, I imagine that would matter, right? Like if you just have an AI system that tells a patient, hey, like in my opinion, you have just an irritated colon and it's nothing to worry about, versus having a doctor say the exact same thing, possibly just downstream from an AI telling them that. Does the mechanism, the person or the thing that conveys the information matter to downstream trust?
It does, but I'm going to separate those a little bit. Currently, just because of the risk associated with healthcare, at least in the United States, but I'm assuming it's elsewhere, the doctor still has to touch. So even if an AI system, can say, oh, it's an issue with your colon, it has to go through the doctor, right? And that's, I mean, issues with liability, FDA. So there's no issue with it getting to the patient and the patient going, ah. In fact, if you look at some of the, information from the watches, right? There's all this disclaimer like, this is not, if it says this, it's not true necessarily. Go see your doctor if your signal from your heart rate is too high, right? Like there's all these disclaimers because of that. So given that, the way information is presented to the user, whether it's a patient or a doctor, does change this aspect of trust, and also, and again, trust in terms of the decision. What we find is, I mentioned the case where if you're expert versus, you're learning, those trust elements change. If you're an expert, you tend to be like, wait, I understand this. This is good. But if you're anywhere below being like 100% solid expert, have been doing this for 30 years, you're more likely to deviate and trust the decision that's coming out of the AI. And again, what they find is that if they give multiple outputs to the user, much better decisions are made.
That does make sense as per the kind of Tesla analogy we were exploring earlier too. I guess final thought on the medical side. What are your thoughts on the on responsibility and accountability if an algorithm's predictions are incorrect? Do you have any opinions about the doctor's role in this? Is it all on them? Is part of it on the developers of the system? Like, how should we parse that?
Yeah, so right now, this is why lawyers are starting to practice in this space, because there is no, so the AI does not become responsible. The developer doesn't become responsible. It really is, again, in this case, it's the doctor or it's the hospital that becomes liable. So typically it's the hospital that's liable because the doctor is doing their best, that kind of thing. This is for healthcare. This is not the case when you're looking at other applications. So we know in the US, for example, we have systems that determine the amount of whether you get out of jail or the years of, go to probation or not. And in that regard, these systems, the judge has to basically discuss why they do not agree with the system.
Oh, interesting.
Versus, which is again, and I think it's because in healthcare, it's thought about as a liability, right? It's like, so if the doctor's like, no, I don't, no, this doesn't make sense. They don't have to create, a 5-page brief about, well, because of this is my thing. They basically say, well, this says this, but here's my other data. And so I'm going to go with this. Whereas in this other system, criminal recidivism, you actually have to explain it. And I think it's because, what's the liability? This person's already in jail. So I let them out earlier or not? Like, what's the liability associated with that? And so I think because of the driving forces, this element of trust and decision-making is different.
Okay, yeah, fascinating. And so many fields get roped into this, which actually brings me to the education piece, because that's another thing you have been working on. Can you speak to that a little bit? Like, what are you doing in the education space, and what are the applications of trust building there?
Yeah, so in the education space, primarily and then of course where I want to get to is using AI to personalize the type of information that is provided to a child based on their learning abilities. Again, working with children with special needs. And so in that aspect, this trust element is to get kids to, interact and believe that these systems are helping them. So that they will continue working with them, even if they, for example, aren't progressing at this rate. And so if you think about in the education space, teachers and parents do this all the time. So you have a student that's struggling. You see that they're improving, but they're still, barely getting that D, right? But you as a teacher, you see that they're doing well. And so what do teachers or parents do? They go, oh, wow, that is excellent work. Even though you're like, yeah, but that's not going to get you to college, but right. And so that's basically a element of, I want to establish that, trusted relationship. I want to still provide you guidance. I want to still get you engaged, but really you're lying. I mean, think about it. You are fundamentally lying. It's a white lie, but you're lying to the child. They're not doing great. They're improving, but you can't just say, oh, you're improving. You have to say, oh, again, choice of words, very powerful. And so when in AI, we're actually looking at this element and looking at this aspect. Can a AI system be deceptive, right? It's a white lie, but at the end of the day, it is lying. It's deceptive if you look at the classical definition of deceit. So what can an AI do? And again, in the education space, to encourage the same way that humans do to kids, but now we actually really have to call it what it is, which is deceit.
Interesting. Okay, and that's loaded, of course, with ethical weight. Yeah. What are some of the responses you get from kids on this? Like, I guess they're, as you mentioned, they're pretty idiosyncratic. Like, they're a very strange bunch. And I guess the special needs probably adds another dimension to it that's interesting. What are some of the reactions that they may have to these systems?
Yeah, so I will segment this. This actual so the engagement we do just straight. We don't use the deceit with the kids because and it's actually because of the risks. So kids, they're formulating their opinions, their behaviors.
Right.
And so to intentionally, the ethical concerns of intentionally lying to a child who's still formulating right from wrong is actually detrimental to their developmental growth, right? So we don't do it with kids and just because of that. And so with there, we just, we basically give them scores, we interact, but we never use words such as, great job when it's not a great job. And so all of our work with looking at this deceit aspect is with adults, adult learners. We're doing things around, learning simple stats, just things that we can get adults, and of course, introducing this deceit aspect. And so the different responses is things such as embodiment makes a difference when you're doing deceit, which was interesting. This element of people tend to not. So we have these scenarios where an agent is deceptive, and then the person is told later on that the agent is deceptive because we want to look at their response and the reaction. And then we give them the ability to punish or reward based on the deception. And so we look at things like helpful
Punish
deception.
or reward the agent.
The agent,
Okay.
right? Based on, oh wait, you lied to me.
This is a robotic agent or like a artificial agent.
Yeah, so we use, again, we're looking at both virtual, so it's basically a chat bot that's communicating versus a physical robot that's it's basically the chat bot on a physical platform versus just text-based.
And the punishments or rewards, are these like, is it like, now I'm imagining ridiculous stuff, but is it like slapping the robot, calling it names?
Oh no, that opens up ethical issues. No, it's monetary. So it's monetary.
Oh, okay.
Right. And so, and why is it monetary? Because monetary leads to these robots have to pay for battery life. And so it's basically, you're taking away their livelihood. So there's a way, and we had to carve out so that we could ensure that the punishment was something that seemed like a punishment, but not something that was, like slapping, which causes
hormonal reaction and all kinds of,
exactly. And so interesting enough, we found a couple of things. One is embodiment has a difference in terms of the punishment and reward system. We also found that people tend to not want to punish, even if it was a very, very drastic lie, like something that harmed the person. People are less likely to punish.
Was there social pressure on them at the time? Because I imagine if somebody asked me like, hey, do you want to punish the system, in public, I might be, well, no, not at all. Of course not. I'm an enlightened citizen of the 21st century here. But is that like a factor? Or?
It isn't. And so, some of the things we need to push, we don't have visual coding of this, right? So one thing is we can look to see, does their body language change? So we don't know if those things. And so this is all based on the text, like, so it's all automated. They're in the room by themselves. They don't know that there's an observer, like none of this. So there's no peer pressure, but some of the things is, can we codify their body language, their eyes, are they diverting? So as you know, when you are making an uncomfortable decision, a lot of times people will divert their eyes as they're processing, right? They're like, oh, this is good. And then like, do I want to punish? And like, I want to punish, right? And so there's characteristics in eye. So that's like follow up, because we have found some of these interesting things are like, oh wait, this makes no sense. Like let's figure this out and go deeper.
What are some of those things?
So One of the things is, so we look at this deceit with respect to harmful versus helpful. So as an example, if you think about, I gave you the education example. Oh, great job, right? We call that helpful deceit, right? It's done in order to help the person themselves. It doesn't help the robot at all. It helps but it's deceitful. And so we look at helpful deceit versus harmful deceit and things like that, and then punishment. So one thing was the punishment aspect, that people, even if it's harmful deceit, like they lie and it not only harms the person but benefits the robot, people are still less likely to punish. Which, you would think, wow, like people really are good, I guess, right? Like, but it's an agent. This
Yeah.
makes no sense. We did find that the embodiment was a big thing. People are more likely to have a connection, an affinity to a physical embodiment, such as a reward structure, more so than the virtual.
That might also play a role when you look at systems like Tesla cars or whatever, right? That this feels more like a thing, like a physical.
I think so. I think it's this aspect of when you are adding in this physical, this 3D space, you're also adding in your own embodiment into the interaction, right? Whereas in the virtual, you don't really see yourself as an embodied other
Yeah.
interacting.
When I think about my actions in the context of a physically embodied system, it feels just physically a lot more consistent with my interactions with humans. Like, even though there isn't a face to look at, I'm more likely, I guess, to wave my arms around or just to kind of physically articulate myself, just because that's kind of the medium I'm in. Whereas if I'm typing, there's no point to like shrugging while you're typing. So maybe that, I wonder if like there's a psychosomatic feedback loop that might be part of this. Is that possible?
There might be, but but and so this is the strange thing, because in these studies you have to keep as many constants the
Right.
same. So even how the person interacts, we have them type. We could do verbal versus not. So we
Mm.
try to make it so that the only variable is the physical versus, but the interaction is the same. They type. In fact, even the robot has it's the Pepper robot, right? It's like it's a screen with the text information, right? And so we try to keep as many variables exactly the same, and
And you
yet we
still,
still have this slight difference.
does this make you generally optimistic about the prospects of the space? Like when you see these kinds of idiosyncrasies, these strange reactions, do you see these more as like opportunities to kind of to do better with our systems, or are these more like risks where it's like, oh, we might be surprised by what we find in terms of trust building. We can't trust that we build a new system and then it'll have the properties that we expect because there's so many weird quirks.
I'm one of these researchers that the things that surprise me are the ones that we tend to explore even more so, because that tells us that there's something unique that we can take advantage of
Mm.
to help us do other things. It's just, and there's one of the famous studies we had in the back a couple of years ago was on emergency evacuation robots. One of the best studies ever, and it was because it came about because the original hypothesis was wrong. And so it was like, oh, okay, let's try to break it. And we could not break it, and we could not break it. And that led to this whole aspect of overtrust when you have these, high risk, time critical scenarios. Um, you even have more of a overtrust, which is like the Tesla, right? When you're in a car and you are at this point of driving, I don't know, 80 miles per hour on a freeway, you are putting a person in this very high risk, time critical decision making loop. You are going to overtrust these systems even more so than if you're just like 30 miles per hour in a neighborhood leisurely, right? Just by being in that situation, in that scenario.
Do you have a sense of why that is? Like, is it that people just the decision is more uncomfortable when the stakes are higher, and so it's easier to offload it, or is it something else?
Yes,
Okay,
yes, yes.
that's quite scary in its own right. Just because I would imagine, yeah, like it's the toughest decisions that we want the help of an AI system for, but those are the ones that we should be second guessing the most.
Yeah, but so this is the quandary, because you are in this heightened state of tension, of stress. We haven't yet, and this is one of the other studies we're going to look at is, do your decisions improve or are they worse? And some prior work, not ours, but some prior work has shown that depending on the person, they're either better during high stress or worse. But it's about a training. So, for example, individuals who are trained in terms of military, they are trained specifically to think during high stress, high risk situations, right? Whereas if you're a grade school teacher, I mean, being in a classroom might be high stress, but
Depends on the
it's
classroom.
not necessarily, yes, yes. Um, and so, we're trying to push that of, is there a point where you want the system to say, okay, this person is capable of doing this versus, yeah, no, it's going to be even more of a disaster if we let them decide or give them the reins.
So in the long-term future, do you see this turning into more of a thing where we just improve these systems to the point where they're one size fits all, or that increasingly we'll see human beings be trained or be assessed by these systems to figure out what the best way to interact with them would be, or some mix of all those things?
A mix of all those things. So I think, my ideal world and why we're still exploring this in my group is I think that when we pair machines with humans in a more symbiotic way, it makes us better. It makes our decisions better in all of these aspects. But the thing is that the way we think and the way we process is slightly different based on our training. I'm an engineer computer scientist. I think differently than some of my friends who might be lawyers. I mean, much differently, right? And so my system, it should basically help me in my decision-making processes based on the way I think versus my friends and colleagues. So we need to get to that stage. And then once we are there, then can we also use these systems to improve some of our values? And we had talked about, stated preference versus revealed preferences. Right. Can we now use these systems to get us to a better place, given that our stated preferences are really the ones that make us a better human?
Yeah, that's its own really interesting thing where, you talk about the assessment of a person, and then if it turns out that it's somebody who doesn't deal well with high stress situations when interacting with the robot, hey, maybe that's something you can improve too, and kind of do the training as part of that. Ayanna, thanks so much. This has just been a fascinating exploration of so many different topics. If people want to learn more about your research, do you have a place where you'd recommend they go?
Yeah, so I always say I post a bunch of different articles always on Twitter, so Robot Smarts, because the research that I do, if I find something really fascinating, I'll be like, everyone, you have to look at this study. It's so good. And so I try to do that, one, to share, not just with my own colleagues, but also with the public. I think that the public is interested in knowing about these elements of trust and bias and the real world version of it versus the media type of version of it. So that's one way. And then, of course, my website is linked to that as well.
Perfect. So we'll provide some links to both those things in the blog post that'll come with the podcast. As usual, everybody who's listening, please feel free to check that out as well if you want more follow-up information there. Ayanna, thanks so much. I really appreciate your time. This has been a ton of fun.
Thank you. Thank you for having me.